morning students. Today we will do the numerical based on the length formula. First of all, let us recall what is the length formula. 1 upon V minus 1 upon U is equal to 1 upon F. As we have done earlier, that V is image, distance, U is object distance, and what is F? F is focal length. Okay, now let us take an example. So let us take an object is placed at a distance of 50 centimeter from a concave lens of focal length 20 centimeter. Now you have to find the nature, position of image. So for this, first of all we have to see which type of lens it is. It is a concave lens. Okay, now we will see what is given to us. First of all, we will write what is given to us. So an object is placed at the distance of 50 centimeter. That means this is the object distance. And object distance is what? That is U. So we have given U, object distance 50 centimeter. As we have read earlier that U is always negative. So minus 50 centimeter. Now what is given to us? Focal length. Focal length is F. How much is it? 20 centimeter. Okay, and we have to find image distance, that is V. Now for this, the focal length is in plus or minus. How can we know this? Lens is what? Convex lens. This is convex lens. In this case, the object is here left hand side and this is right hand side. Anything which is present in the left hand side, these are negative, and object or image, if it is present on right hand side, then it is positive. And in this case, the focal length is this side. That is why the focal length is always again in the negative. That means in the case of the concave lens, the object U and the focal length both are in the negative. Okay, now we have to find out the image distance, and this is the lens formula. So you have to write the lens formula. 1 upon V minus 1 upon U is equal to 1 upon F. Now put the value of U and F in it. We have to find 1 upon V. Take 1 upon U this side. That means 1 upon F minus, it becomes plus. Here it is negative. When it goes this side, it becomes positive. Now focal length is 1 upon 20 plus 1 upon minus 50 plus minus become minus. Good. Minus 20 minus 50. Now take the LCM of 20 and 50. What is the LCM of 20 and 50? 100. Very good. 100. Now if we solve it, minus 5 minus 2. Minus and minus become plus, but sign of minus. Minus 7 upon 100. This is the value for 1 upon V. Now we want to find the value for V. So we will invert it. V is equal to 100 upon 7. Okay, now divide 100 upon 7. It becomes minus 14.3 centimeter. So we have find out the value for V, that is minus 14.3 centimeter. Let us take another example. An object placed 50 centimeter from a lens produce a virtual image at a distance of 10 centimeter in the front of lens. You have to find the focal length of a lens and the magnification. Now, in this case, only virtual images given to us. So, we have to find out which type of lens is it. So, the lens which is always from the virtual image is concave lens. So in this case we have taken the concave lens. Now what is given to us? Object placed at 50 centimeter. That means object distance. U is 50 centimeter. U is always negative. Now lens produce a virtual image at the distance of 10 centimeter. That means this is the image distance. V is minus 10 centimeter because it is a concave lens. Concave lens, if in the concave lens image is formed in this side and this is left hand side, and anything which is in the left hand side is always negative, and we have to find out the focal length. Now apply the length formula. 1 upon V minus 1 upon U is equal to 1 upon F. Okay. Now we have to find out the focal length. Put the value of V and unit. V minus 10 minus 1 upon minus 50 is equal to 1 upon U. Minus and minus become plus. 1 upon minus 10 plus 1 upon 50 is equal to 1 upon F. Now to take the LCM of 10 and 50. What is the LCM of 10 and 50? 50. So 50 and 5 plus 1 is equal to 1 upon 5. Now plus minus 4 upon 50 is equal to 1 upon F. You have to find out the value of F. Reciprocal it. 50 upon 4. Divide 50 upon 4. The value of F comes to be 12.5 centimeter. So we have find the focal length. Now we have to find the magnification. So what is the formula for magnification? Magnification is V upon U. Always keep in mind that in the formula of length, 1 upon V minus 1 upon U. If here it is minus, in magnification it is in plus form. M is equal to V upon U. In the case of mirror, the formula is 1 upon V plus 1 upon U is equal to 1 upon F. This is mirror formula. And in this case, when we find the magnification, it becomes minus V upon U. And in the length formula, the magnification becomes V upon U. Now we have to put the value of V and U. What is the value for V? Is minus 10 and the value of U is minus 50. Minus cancel out. M is equal to 1 upon 5, that M becomes 0.2. So our magnification is 0.2.